Good evening. Good evening, everyone. Okay. Today's talk is once again on work energy theorem. Today, I would like to apply based on, this one. Okay. Next one will be there. Later on, we'll discuss. Okay. So this is work energy theorem as applied to particle speed. Okay. So let me just recall what we have done so far. The first lecture in the series was something like work energy theorem in free fall. You drop an object and you find out, okay, what is the speed of the particle when it reaches. And I had done this with three methods. Okay, one is by kinematics method, other one is work energy theorem, other one is conservation of energy. Wow, whichever method you want, you can take it up. Every type of food is available. You go to a hotel, he will give you a list of menu and you can choose whichever you want, like this. Okay, let us look at the second one. So second one was also very similar. We use work energy theorem for a particle moving in an incline. Here also I had told you about two different methods. Is it two different methods? No, I have given you three different methods. Okay. The first method was by using the kinematics method. The second method was by using work energy theorem. The next method was using conservation of energy method. And work energy theorem and conservation, and work energy theorem and kinematics. I have combined these two together. And the last method was treating force and displacement as vectors and finally get an answer. Okay, so there are three methods here also. Let us look at the next one, which was yesterday's video. We saw something like the interest was to find out what is the work done and whose velocity decreases with respect to time, which is being shown over here. Okay, increases or decreases, whatever it is given over here. And thus we found out, okay, how do you use this? You can derive this using your kinematics method or maybe work energy method. Both the method you can do it. Now today, we will start with one more. Work energy theorem as applied to a particle speed. Okay, now what is given to us is, the problem reads like this. Work done in moving a particle from x equal to 0 to x equal to b. Okay, what is x equal to 0? What is x equal to b? Let's say I can give this as 3 meters, 4 meters, whatever it is. Okay, x equal to 0. This is my origin. This is my origin. X equal to b. B is this point. X equal to 0 and x equal to b. Wow, great. Okay, which means the distance here is nothing but b. Distance here is b. Okay, I'm just breaking the problem to let you know. Then the speed is proportional to square root of displacement. Speed is proportional to square root of displacement. The mass of the particle is 1 kg. Mass of the particle is 1 kg. And it started from rest. That means its initial velocity is 0. Okay. Now, how do we start? Let us start with the first method, kinematics method as usual. What do we do in kinematics? Now, if you look at this, we have got an equation, V is proportional to root x. To apply kinematics method, the first thing that we should know, that is the equations of motion. If I want to apply, the acceleration should be constant. Now, what I will do is, I do not know whether acceleration is constant or not. Let me square this. V square, okay, before squaring, since it's proportionality here, I'll write this V is proportional to, I'll remove this proportionality sign, and I'll write this as k times root x, where k is the proportionality constant. Thus, I can write V square equal to k square into x. Now, if you recall the set of equations you have learned so far, what are the equations you have learned? You have learned V square equal to u square plus 2x, right? One of the equations of motion is V square equal to u square plus 2x. Okay, sometimes in the problem, this could be given. Sometimes they may not give you also. Okay, this is not required here actually. This is not required over here. So as a result of it, you see V square is equal to 2ax. Instead of 2ax, is a k square here. Okay, where k is a proportionality constant. If k is a constant, then definitely this 2a is also a constant, right? Because I am just comparing this equation with this equation, and I have substituted u equal to 0. So this equation now results into V square equal to 2ax. And here I see V square equal to k square into x. So comparing this, okay, V square equal to 2ax and V square equal to k square x, I can see 2a equal to k square. 2a equal to k square. I hope you got the idea. And thus I get a is equal to k square by 2. Okay, we have got the acceleration of a particle given by a equal to k square by 2. What does it tell you? It tells you that the acceleration is constant. Okay, a equal to k square by 2. It's making me more angry. Okay, so a equal to k square by 2. Now we have got this. Now how do you find work done? When the acceleration is constant, force definitely is constant, right? We know that F equal to ma. F equal to ma So force definitely should be constant because A is constant, M is constant, force should be constant. If force is equal to constant, then I can write work done is equal to force dot displacement. And see, I have drawn as a straight line. Okay. So therefore, this should be F is what? F is M into K square by 2. I have known that the value of M is 1 kg. So therefore, F is equal to A here. So I can now write this as K square by 2 into what is displacement? Displacement is nothing but this path traveled, B. It is B. Okay. So thus the answer should be half K square into B. Okay. So the work done by the particle in moving from x equal to 0 to x equal to b, okay, when starting from rest is nothing but half k square into b. Got it. First method is done. Now let us do the same work by second method. Which method will I prefer? Second method. See, this you can use it at the 9th grade level. Okay, 9th, 10th standard, you can use this one. Let us do the second one, which I already you already know about work energy theorem, because the focus is totally on work energy. Now, how do I apply work energy? Now towards it. Now you see, I have written v square equal to k square x. V square equal to k square x. Now if I ask you what is the velocity at x equal to 0, at x equal to 0 here, okay, so I can say put x equal to 0 here. So thus you get v square equal to 0. This implies v is equal to 0. Then what is the velocity at x equal to b? Velocity at x equal to b is substitute x equal to b here. Thus you get v square equal to k squared into b. This implies v square is equal to bk square. Okay, I am writing the same thing. V square v should be equal to k root b. K root b. That's what we have. Wow, very easy, right? And then next, this is my second method I'm doing. So I have just substituted these two. Now what does work energy theorem state? Work energy theorem states the work done by the particle should be equal to kinetic energy final minus kinetic energy initial. Okay. So therefore, the difference in kinetic energy, that's what it tells you. So what is the kinetic energy final? Half mv square at this point, because this is the final point. So this should be half m into v square. What is v square? See, it's k square into b. K square into b minus what is the kinetic energy initial? V equal to 0. The kinetic energy is 0 minus 0, which should now be equal to half m. M is 1 kg. I'll substitute that and I'll get the answer k square b by k square into b divided by 2. See, which is the same answer here, right? So we have got the same answer using work energy theorem also. Wonderful. Okay. Now, so this can be applied. Now you see, because v is proportional to square root of x and we just have substituted this value. We are not bothered what is the force acting there, whether it is constant. We didn't do all these things here. Okay, very easy method, right? We just came to know what was v at the final point, what is the v at the initial point, and finally you just took the difference between the kinetic energy, squared it, took the difference, and you finally got this. Okay, done. Now what I will do is let us go with the third method. Third method, which I would not advise for a 9th or a 10th grade student to look at it. This could be useful for a 12th grade student, 11th or 12th. Okay, so in 11th or 12th, what do? You learn calculus. Okay, I assume that you know a little bit of calculus over here. When you say I know a little bit of calculus, now you see what is the expression I use? I can say the work done by an object is given by W is equal to 0 to B of F dot dx. F dot dx. Okay. Now towards it. Now what is F? I do not know what's the value of F. So now we need to find out the value of F. See, I got the value of F from here. See, F is equal to MA, and so I will start doing all this work. Okay, and I'll get the value of A. Let me write it down. I'll write W is equal to 0 to B of F is nothing but M into A into dx. Right? I have written something like this. And what else I can do? Shall we do something else over here? Okay. Now I have V proportional to x or V equal to K root x. Okay. From this expression I need. Just a minute. Somebody at the door. Okay, I'm back. Where is my cursor? It's here. Okay. Now I have this. Now what I will do is I will take V equal to K root x here. Okay. So V is equal to K root x. And now what is acceleration? I want for acceleration, because this m is 1 kg, I can directly substitute. I can write 0 to b of a into dx. I can write like this. Now, this a I want. How do I get A from V? Simple. A should be equal to dV by dt. dV by dt. Now I can write this as dV by dx into dx by dt. dx by dt. Now, what is dV by dx? See, differentiate this, which means that dV by dx is now equal to k into 1 by 2 root x, 1 by 2 root x into d, and yeah, dV by dx is so much. dV by dV, we have differentiated this with respect to x. I get this value. So I will just substitute k for dV by dx. I'll substitute k by 2 root x. Just a moment. Yeah, k by 2 root x into what is dx by dt? dx by dt is nothing but velocity. I'll write this as velocity only. Okay. Now, what's the value of velocity? See, we already got, where is velocity here? See, v is equal to k root x. Velocity is k root x, right? I'll substitute it over here. I'll write this as k by 2 root x into, what is v here? V is k root x once again. K root x. Okay. So therefore, this root x and this root x cancels. So what is the answer I'm getting? I'm getting this as k square by 2. Okay. Now, I'll take this value. So what is this value? A. I take this value of a equal to k square by 2 and substitute in this equation. So w should be equal to 0 to b of a, which is nothing but k square by 2 into dx. Okay. So which will now be equal to, now you see this is a constant. I can remove this from the integration. K square by 2 into, or integral of dx. What is integral of dx? X, and this is 0 to b, which would now be equal to k square b divided by 2. I have just applied upper limit minus lower limit. Okay, b minus 0 I get. Okay, so therefore it is half k square b. Now, did we arrive at the same equation? See, here also we got an equation which is half k square b. Here also we got half k square b. Here also we got half k square b. Now, which method do you think is easier for you? If you want to work with this, you need to know some amount of technical details. You need to apply your equation. The main problem here is that how did I know that v square equal to k square x, and how did I equate 2a equal to k square? That was the thing. Until unless you know, okay, so that it follows the pattern of equations of motion, you will not be able to do this. Okay, and then you need to find out that acceleration is constant, and then you need to find. See, this method is applicable only when the acceleration is constant. But this method is independent of acceleration, right? You only need to know what is the final velocity, what is the initial velocity. You already had everything. Just substitute it and you get the answer. This method, definitely people will think, "Arey yaar, kya kar raha hai?" One, if you want to prick a nail, you can. You are doing it with a hammer, not with a nail cutter. Okay, so this is something like very much trackable. Okay, so therefore, but only thing is you should know how to apply all these methodologies. That's what I'm sharing it across. Okay, so with this, we are still able to prove the same result with the help of 3 different methodologies. Okay, so then you can decide which method you would like to work on and what is it you would like to use. So thank you, friends, for watching this. I am very happy to say that as of today, what is the date today? Yeah, okay, so as of today, today's lecture, we have reached 101 subscribers. Thank you for all your appreciation, and looking forward to increase the count. Thank you. Like, share, and subscribe to my channel for further updates. You can share it with others so that it will be helpful for others also. Thank you.